Alright y'all, sorry for being out today. I had an eye appointment that I had to take today, so I will see you back tomorrow. I'm fine, everything's good. So this is the paper from yesterday that you practiced and turned in, and I want to go ahead and start by going over that. So for the first 10 we had two lines. We want to know, are they parallel, perpendicular, or are they just neither of those things? So all we're really looking at is the slope, okay? So for number 1, 2x minus 3 and 2x plus 3 have the same slope. Since they have the same slope, they're parallel. For number 2, 4/3 x, so the slope is 4/3, and 3/4, and I realize there's no x there. Now, 4/3 and 3/4 are not the same fraction. Now, they're both positive. For it to be perpendicular, remember you have to have the opposite reciprocal slope. The opposite of 4/3 is negative, okay? So this is neither. Number 3, we have a slope of 3 and a slope of -1/3. That is perpendicular. Another way to check and see, hey, are these guys perpendicular, is if you multiply the two slopes together. 3 times -1/3. The product of those two slopes is always going to come out to -1. So that's a good way to check and make sure, okay? So, 3/2 and 2/3, those are not the same slope and they're both positive, so they're neither parallel or perpendicular. We've got +5 and -5. Well, one's positive and one's negative, but this is not the reciprocal. -5 is not the reciprocal of 5, so this is also neither. We've got 3/4 and 3/4. Hey, those are the exact same slope, parallel. We've got 1/5 and we've got -5. Well, the reciprocal of 5 is 1/5 and vice versa. And since one is positive and one is negative, I'm thinking those are perpendicular. But I'm going to just double check by pulling up that fraction template and multiplying 1/5 times -5. And hey, anytime that the product of those two slopes comes out to -1, they're definitely perpendicular. So we've got, -1x and 1x. So here, this is -1. Here, this is 1. Well, the opposite reciprocal of 1 is -1. And if you have to, you can multiply -1 times 1 to see that these guys are perpendicular. Oh, we don't have a fraction here, we have a decimal. But the slopes are still pretty easily identifiable. 0.5x and 0.5x, those are the same slope, parallel. And then 2.5x and -0.4x. You know, I think it might be easier to see if these guys were fractions. So to change a decimal to a fraction, we're going to type that decimal in, hit math frac, and we see that that is a slope of 5/2, and then -0.4 math frac is -2/5. Yep, 5/2 flipped upside down and negative, those are perpendicular. You can also use that -1 trick. 2.5 times -0.4 is -1. Okay, so for 11 and 12, we wanted to write the equation that is perpendicular to this equation and goes through -5, -3. So, I've got everything I need for point slope form. Remember, point slope form is this guy, y minus y1 equals m times x minus x1. So, if we're going parallel, then the m, the slope that I need, is just 3. And then the x1, y1, x1 is just -5, y1 is just -3. Just the x-coordinate and the y-coordinate from this point. Okay? So I'm going to set up point slope form as y plus 3. Remember, you do y and the opposite of the y-coordinate. equals the slope 3 times x, and then the opposite of the x coordinate would be x plus 5. And then we will distribute 3 times x and 3 times 5. 3 times x is 3x, 3 times 5 is 15. And then I'm going to subtract 3 from both sides to get y equals 3x plus 12. Okay, number 12. We're going parallel to y equals 1/2 x minus 3, and it needs to go through 24, negative 7. The parallel slope is still 1/2. I'm going to use this point to say that x1 is 24 and y1 is negative 7. So for point slope form, y minus y1 is going to be y plus 7. Change that sign. Equals m, the slope is 1/2, times x minus x1, x, and the opposite of the x coordinate would be x minus 24. Distribute that 1/2. Luckily that's not too bad. 1/2 times x is 1/2 x. 1/2 times negative 24 is negative 12. So I've got y plus 7 equals 1/2 x minus 12. Then get y by itself by subtracting 7 from both sides. Negative 12 minus 7 is negative 19. Okay. On the back, we had 2 more that we wanted to write the equation of a perpendicular line. So, for number 13, perpendicular to y equals 3x plus 4 and goes through 9, 2. So, if we want to go perpendicular, we're not going to just use the slope as 3. We're going to use the perpendicular slope, which, okay, since 3 is positive, we know our perpendicular slope is negative. And then, let's see, 3 is the same thing as 3 over 1. If I flip those upside down, I get 1/3. So the perpendicular slope is negative 1/3. Verify that that works if you have to by multiplying the slopes. Negative 1/3 times 3 comes out to that magic negative 1. x1 and y1 just come from this point. So x1 is 9, y1 is 2. So if I go for point slope form, y minus y1 equals m times x minus x1. That should be y minus 2 equals negative 1/3 times x minus 9. Then distribute that negative 1/3. Negative 1/3 times x is negative 1/3 x. Negative 1/3 times negative 9 is positive 3. Add 2 to both sides. 3 plus 2 is 5. The answer is y equals negative 1/3 x plus 5. For number 14, we wanted to go perpendicular to y equals 5/4 x minus 2 and goes through 20, negative 3. So the perpendicular slope is not going to be 5/4. But if I just flip that 5/4 upside down to be 4 over 5 and then make it negative, I've got the perpendicular slope. Since it started out positive, make it negative, flip the fraction upside down. If you have to, check that the product of those two slopes Negative 4/5 times positive 5/4 comes out to negative 1. X1 is 20, Y1 is negative 3. So Y minus Y1 equals M times X minus X1. That's going to be Y plus 3 equals the perpendicular slope, negative 4/5, times X minus 20. Negative 4/5 times X, negative 4/5 times negative 20, gives you negative 4/5 X plus 16. And then subtract 3 from both sides. (16 minus 3 is 13. Okay, so the big deal with perpendicular is that you need to use the opposite reciprocal slope. So flip the fraction upside down and change the sign. If it was positive, make it negative. If it was negative, make it positive. Okay, the Reading Railroad is building a new rail line. They've already greenlit a new station, so it's right here, as shown in the diagram below. However, due to a pre-existing agreement between the owners of Reading Railroad and the competitor Pennsylvania Railroad, their tracks must run parallel to each other so that the two sets of tracks never cross. Write a linear equation that could be used to represent the path that the owners of Reading Railroad must lay their tracks. Okay, so let's go ahead and start by identifying a few points here. The Reading Railroad station is at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 3. That's going to come in handy in a little bit. Okay? We've also got these two stations for the Pennsylvania Railroad. I'm not too concerned about where they are in terms of using point slope form, but I do need these 2 points because I don't know the slope of Pennsylvania Railroad. So the slope that is taking these tracks through these 2 points. So that station A is at 2, 1, 2, 3, 4, 5, 6, 7, 8. And B is at 1, 2, 3, 4, 5, 6, 7, 8. And up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so we need to first find the slope, because if we want Reading Railroad to be parallel to Pennsylvania Railroad, we need the slope of Pennsylvania Railroad, because it's going to be the same slope as for Reading Railroad. So the slope is found as y2 minus y1 over x2 minus x1. y2 would be 11 minus 8 over 8 minus 2. 11 minus 8 is 3, and 8 minus 2 is 6, and that will reduce to 1/2. And you can see that just by looking at the grid. Those like points where it lines back up with the grid, it looks like the tracks are just going up 1 over 2, up 1 over 2, up 1 over 2 every time. So that's why that slope is 1/2. Okay? So we want a linear function that takes us through the Reading Railroad station at 13.3 and has a slope of 1/2. Well, that's everything we need. We're going to call 13.3 our x1, y1. We're going to use the same slope, m is 1/2. And I'm going to set up point slope form. Y minus y1 equals m times x minus x1. That would be y minus 3 equals 1/2 times x minus 13. So, distribute that 1/2. 1 half times x is 1 half x. 1 half times negative 13 is negative 13 halves. Then to get y by itself, we're going to add 3 to both sides. That's going to give you y equals 1 half x, and then negative 13 halves plus 3 is the same thing as negative 13 halves plus 6 halves. It's going to come out to negative 7 halves. You can just verify that in the calculator. If you type in negative, pull up the fraction template, 13 halves plus 3 comes out to negative 7 halves. So the equation that would take us through this railroad and have the parallel slope to Pennsylvania Railroad is this. So that is the path that they need to follow to lay down those tracks parallel. For number 16, in a parallel universe, haha, get it? The agreement between the two owners is actually that they need to be perpendicular. Write a linear equation that can be used to represent the path that the owners of Reading Railroad must lay their tracks. So, basically the same question, point has to be in the same, or the railroad station is already in the same place, but instead of running parallel, it's going to run perpendicular. Okay? So, we still know that x1 is 13 and y1 is 3, but we just need a perpendicular slope. Well, the original slope for Pennsylvania Railroad was 1 half. So the perpendicular slope would be negative, flip that upside down, 2 over 1, or just negative 2. Okay? So, set up point slope form. We get y minus 3 equals negative 2 times x minus 13. So believe it or not, this felt like it was going to be, oh my goodness, the whole entire new question. It really wasn't all that much work. It's the same thing that we did right here, just a different slope. So distribute negative 2 to get negative 2x plus 26. And then add 3 to both sides. So the perpendicular slope would be y equals 2x plus negative 2x plus 29. Okay, so I need you to do me a favor. Put this paper in your binder at the end of chapter 3, so after yesterday's notes, okay? And then while you're in your binder, go to the chapter 3 table of contents and write down parallel and perpendicular lines part 2 with today's date on it, 3/2. So again, put this paper in your binder at the end of chapter 3, and then in your chapter 3 table of contents, lesson 17, parallel and perpendicular lines part 2. At the same time, you're going to be getting a new piece of paper from your substitute that looks like this. So if you will put your name and today's date up there. And with this paper, there are 6 graphs, 3 on the front and 3 on the back. And there's also this little red half sheet of paper that has a bunch of equations on it. So this is a cut and paste activity. All we're going to do is first find the original equation for each of these graphs, then write the equation of a line that runs parallel through that point, and then write the equation of a line that runs perpendicular through that point. So let's go ahead and do one together. You're also going to need scissors and glue. Those should be sitting on the table where your binders are. So on the table right in front of the bookcase should be all of these scissors and glue sticks that you need. Please make sure that I get my scissors and glue sticks back, and please put the glue sticks, the caps back on top of the glue sticks. I'd appreciate that. Okay? So, for number 1, first just looking at the graph. It looks like the y-intercept is -2, and it goes up 1 over 2, up 1 over 2, up 1 over 2. So, ignoring this point out here for a second, I'm thinking we're looking for y equals 1/2 x minus 2. So looking at this paper, I think we're looking for option D. So what I'm going to ask that you do then is grab a pair of scissors and cut option D out. And then once you have option D cut out, just glue it down in that box. So where's my glue? Okay, so now we want to write the equation of a line that runs parallel to this line that goes through this point hanging out up here. Okay, so if I'm going parallel, I know that I need to have the same slope. Okay, so how I'm going to do this is I'm going to go ahead and set up the kind of outline of point slope form and kind of piece together some information. The slope needs to be 1/2 again, otherwise they're not going to be parallel. And if it needs to go through this point is -2, 3. So I'm thinking we're going to say y minus 3 and x plus 2. Again, it's got to have the same slope, otherwise they won't be parallel. And then if it goes through -2, 3, we're going to have y minus 3 and x plus 2, the opposite of these two numbers, grouped with the y and the x. Then complete 2 steps to solve the equation, solve for y. We're going to first distribute 1/2. One half times x is 1/2 x. 1/2 times 2 is 1. Then add 3 to both sides. You end up with 1/2 x plus 4. Now looking at my remaining options, I see that in the bottom left corner, it's q, y equals 1/2 x plus 4. So I'm going to cut q out. And then glue q down. Okay, for the perpendicular equation, I need the slope to be the opposite reciprocal. So it's not going to be 1/2 again. It's going to be -2. So if I flip 1/2 upside down, I get 2 over 1, make it negative. So go ahead and set up our point slope form outline. The perpendicular slope is going to be -2. It still needs to go through -2, 3, so y minus 3 and x plus 2. The only difference between what we did here and what we did here is the slope. Okay? So, once you've got that, do the same steps you did here. Distribute negative 2. Negative 2 times x is negative 2x. Negative 2 times 2 is negative 4. Then add 3 to both sides. We end up with y equals negative 2x minus 1. And that is option C. So cut that out, glue it down. Okay. If you want, you can look at these and say, okay, let me graph 1/2 x plus 4. So that would be like this, which does run parallel. And if I graph negative 2x minus 1, I would start at negative 1 and go down to right 1, down to right 1, up to left 1, up to left 1, up to left 1. And so we do get 2 lines that go through that point. They both go through this point. One is parallel and one is perpendicular. Now, do you need to draw the parallel and perpendicular line? Absolutely not. Do not worry about that. All I'm looking for is the work that shows this parallel line and this perpendicular line that go through that point. Okay? Let's do number 2 together as well, just to make sure we're all on the same page. I'm going to give you just a moment to catch up on number 1 if you need. Okay, number 2. Not worried about this point yet. I want the original equation. Now, the y-intercept is negative 4, and the next point up here is 3 steps up and 2 steps over. Since that goes up 3 and over 2, I know I'm looking for y equals 3/2 x, 3 over 2 times x. And then since the y-intercept is negative 4, y equals 3/2 x minus 4. So looking at those options, that's A. Y equals 3 over 2x minus 4. So let's cut that out and glue it down. Okay, so I know the slope is 3 over 2. So for my parallel equation, I'm looking for y equals 3 over 2x and then something else. That something else is going to be determined by this point. Okay, so I need it to go through negative 2, 1. So setting up my outline of point slope form, I need the same slope, otherwise they won't be parallel, so I'm going to put a 3 over 2 here. If it needs to go through negative 2, 1, I'm going to write y minus 1 and x plus 2. Then distribute and solve for y. So 3/2 times x 3 halves times 2. 3 over 2 times x is 3 over 2x. 3 over 2 times 2, well, 3 times 2 is 6, and 6 divided by 2 is 3. So I get y minus 1 equals 3 over 2x plus 3. Add 1 to both sides. Three plus 1 is 4. Looking at the remaining options, that is option E. So we're going to cut that out and glue that down. And for the perpendicular equation, I'll go ahead and set up my point slope template. And it's got to go through the same point, so it's still y minus 1 and x plus 2. However, for the perpendicular slope, 3 over 2, if I flip that upside down, is going to become 2/3. Then just change the sign to make it negative. Remember, if you're ever unsure, do I have the correct perpendicular slope? Multiply them in your calculator, it better equal -1. So 3 over 2, 3 over 2 times -2/3. 3 over 2 times -2/3 comes out to -1. That's how I know that I have the perpendicular slope correct. This slope times that slope has to equal -1. Then do the same thing we did right here. Distribute -2/3. -2/3 times x is -2/3 x. -2/3 times 2 is -4/3. So I've got y minus 1 equals -2/3 x minus 4/3. I'm going to add 1 to both sides again. Here, when I add 1 to both sides, I've got to either find the common denominator or make my calculator do that. -4/3 plus 3/3 is -1/3. If you want to use your calculator, -4/3 plus 1 is -1/3. And that is option T in the bottom right corner. And that is it. So you have one more graph on the front and 3 more graphs on the back. I need you to write the original, or find the original equation, perpendicular and parallel equations using these remaining options. There will be 2 left over. So there are 2 of these equations that you're not going to use. Whenever you finish, please make sure your name is on this paper and turn it in. And then any scrap paper, so the 2 extras, or any of the little clippings that you have, make sure that those end up in the recycling bin, okay? So I'm going to leave this up here just in case you need to get caught up for a second. For the rest of class, I want you to finish those other 4 graphs. So the equation, parallel and perpendicular equation, and then turn that in. If you have additional time whenever you finish, work on the homework that is due tomorrow. I hope y'all have a great day. Be good for the sub, and I'll see you tomorrow. Bye.